recording? All right, we're good.
Uh, Good evening, everyone, and welcome to the HeatSmart Southern Tier program. My name is Matthew Tilley, and I'm one of the Energy Corps interns for the Network for Sustainable Tomorrow. Today, you are going to learn about clean heating and cooling technology and energy efficiency to decide if a free home assessment is right for you. Next slide. So before we get started, I would like to mention that we have one more webinar left for our HeatSmart Southern Tier campaign. It will be this upcoming Wednesday next week, where one of our clients is going to give us a virtual tour of his home that has had AirSource heat pumps deployed. So if you are interested in adding them to your own home, you should definitely go check it out. Next slide. So the Network for Sustainable Tomorrow is a nonprofit organization that is funded by NYSERDA, which is the New York State Energy Research and Development Authority. In addition to our HeatSmart Southern Tier program, we have a solar program that we will get into later. And another program we have is Binghamton Community Power. Next slide. So we are going to talk about our program and some of its value propositions. Then we will dive into our various technologies, including weatherization and heat pumps. Then after that, we will get into money and how you can participate, and then finish with a Q&A. Next slide. So we are one of 15 HeatSmart programs existing across New York State. These community outreach programs are all funded by NYSERDA, and our programs help to provide local experts that are not installers to provide a non-biased viewpoint of these technologies and what the process entails for deploying them into one's home. Next slide. So as you can see from this visual here, it provides a good idea of what the major contributors are to greenhouse gases in New York State. The main one is transportation, but heating and cooling buildings is close behind it. Then following that is electricity, waste, and industry. New York State is focused on the greening of electricity, but as you can see, that is not the main problem. It would be good if we incorporated electricity into all aspects of buildings and transportation. We already understand how electric and hybrid electric vehicles function, but in terms of buildings, there's not been a breakthrough for electric heating with heat pumps, which we will talk about. Next slide. So some top level benefits include reducing energy costs, both short-term and long-term, improving the comfort of your home, and reducing climate change. It is ideal that everyone becomes energy literate, not only because some of us will be working in that industry, but because we will eventually need to replace our existing transportation and manufacturing energy systems. And what better way to do so than with clean energy? Next slide. So these are the technologies we are going to cover tonight. We have weatherization, which is home insulation and air sealing, and then ground and air source heat pumps and heat pump hot water heaters. Next slide. So our installer partners are competitively selected by NYSERDA through a request for proposals process. And these are our partners we have decided on currently. For our AirSource heat pumps, we have AirSource LLC for Broome, Tioga, and Chenango counties, and then D&D Refrigeration for Delaware County. For ground source heat pumps, we have Dailey Geothermal, and then for our insulation partner, we have the Insulation Man. Next slide. So the first step to all this is weatherization. Next slide. Before you deploy heat pumps, it is important to check that your house is not leaking a lot of energy. This is because heat pumps work better when your house is tighter, and you do not want to have more heat pumps than needed so that you can save money. If you are heating the outdoors, your system could also be oversized, so it's better to have a smaller system for that. So what all this involves is an energy assessment starting at the front of your house, followed by a walkthrough of the home's interior and exterior. The safety element to this assessment is the combustion safety test, where we want to make sure that all combustible appliances have all of their fumes leaving the house. Followed by that is infrared cameras that we use to see peek inside the walls and other surfaces to find out what you have in there in terms of installation. Then is the blower door test, which allows you to gauge how much leakage there is in the home. And then finally, you will receive a report with an estimate. Next slide. So this is a mock-up of the home. You have cold air that is being drawn in and the hot air rising because of the thermal stack effect. And to the lower stories coming through to the basement where the air is not the greatest, and then drawing the heated air out of it. In terms of getting your money's worth, number one is to seal up those leaks, and then number two is to put in insulation. Next slide. We are now going to move on to our various heat pump technologies. Next slide. So you may not know it, but heat pumps can actually be found in your refrigerators and freezers. At the center of a heat pump is a compressor, which makes things hotter. You can use that heat to go in the direction of heating up a space or cooling it. Next slide. Here's a breakdown of what the different technologies offer. The ground source heat pumps can do it all, and the air source heat pumps can heat up and cool spaces, and heat pump hot water heaters can heat up hot water. Next slide. So what ground source heat pumps do is they take the constant temperature that can be found underground and use it to heat up or cool your house depending on the time of year. They can get very hot, and typical ground source heat pumps can heat up to around 150 degrees. This is all distributed throughout your house, and typically people that have ducted systems in their distribution systems in their house, but it is also possible to achieve this with hydronic, radiant, or baseboard water distribution systems. There are also two kinds of loop fields, horizontal and vertical. Horizontal loop fields are better if you have a good amount of space that needs to be heated up or cooled. So the point to that is that you want to have a surface area of a sufficient amount of pipes. Next slide. So why a ground source heat pump? Well, first of all, they are an efficient form of heating. A home system could get as efficient as 600 to 700%. So for example, if you're putting in 1 unit of electricity, you are getting out of that 6 or 7 units of heating. These can last a long time, around half a century, and they are typically warranted for, heat pumps are typically warranted for a decade. There are also, in addition to this, there's no longer fossil fuels being used in your home, so you no longer need to worry about the expenses of deliverable fuels such as propane or oil. Next slide. Air source heat pumps use the same technology as ground source heat pumps. They draw heat out of the air and bring it into a system where the refrigerant boils by being compressed at a low temperature, and then the heat is distributed throughout the house. Air source heat pumps can involve an outdoor unit that can be linked up to one or more multiple indoor units. This allows you to bypass your existing distribution system altogether. You can also continue using your existing heating system if necessary, although heat pumps today do not require much help even in the coldest of temperatures. As you can see, there's a number of different styles you can choose from for the indoor units depending on your aesthetic and how much they can heat and cool a space, and also the price. Next slide. Some of the benefits of air source heat pumps, in addition to their energy savings, include air conditioning without ductwork, no need for full heating replacement, and also their flexibility and quietness. Next slide. So the last thing for our technology section is heat pump water heaters. What this is basically an electric water heater with an air source heat pump on top of it. These can cost more than typical gas heaters, but they are more efficient, and the heat pump provides an extra boost. You can only install these in an appropriate space because they need air in order to function. So an ideal space for them would be one that is semi-conditioned, like a basement that is not fully finished. A very cold basement will make the electric part of it work more difficult, but it will still deliver benefit. Next slide. So now I will pass it on to my fellow intern, Olivia Price, who will talk about the incentives.
Great. Thank you, Matt. Hi, everyone. My name is Olivia, and I'm also one of the Energy Core interns for HeatSmart Southern Tier. Ellie, if you want to go to the next slide. So as you can see, there's a lot of incentives available to make heat pumps more affordable. Right here, we have all of the available NICEAG incentives for residential units for each technology. For AirSource heat pumps, they all must be cold climate heat pumps. You can see the details in the far right column as far as to what equipment is eligible, and this depends on if you are heating your entire home or if you're just heating part of it. For ground source heat pumps, NICEAG offers $1,500 per 10,000 BTU hours of heating capacity. For domestic hot water heaters, there is a variety of incentives. The heat pump water heater is the most common with an incentive of $700 per unit, but we can go a little more in depth with this in the Q&A. Next slide. So as far as federal tax credits go, NICEAG is currently now offering a 22% tax credit for ground source heat pumps. Next slide. For financing, there are a number of different options available. Right now, NYSERDA has 3 different types of loans out there. They all allow you to borrow up to $25,000, and all of these loans are at fixed rates with 5, 10, or 15-year terms. If your income is below 200% of the area median income, then you will get the lower 3.49% interest rate. But if it's not, then you will get the higher interest rate of 6.99%. There is also manufacturer financing available for both air source and ground source heat pumps. And it's also an option for you to check with your local bank because sometimes they can offer rates that are actually quite competitive with NYSERDA's rates. And I just also want to mention that other than the free audit that you'll receive if you do decide to sign up, there are no energy efficiency incentives from NYSERDA. Next slide, please. So now I wanted to talk a little bit about the income eligible programs for low to median income households. The first is Assisted Home Performance with Energy Star, and this program will provide a discount of up to 50% of your project's cost. This program has a limit of $5,000 for a single family residence, and if you're a landlord with a multifamily unit, they offer up to $10,000 for your project. Eligibility for this program was expanded up to 120% of the area median income through March 31st. Those income numbers are right there in the chart on the right. And then this program also includes heat pumps. Next slide. Another program out there is the Empower program. This program is available to homeowners that are under 60% of the state median income. As again, you can see if you qualify based on the chart on the right. With the Empower program, you can receive free assessments and energy improvements, and the max award was actually temporarily increased to $10,000 until March 31st. And then this program also includes heat pumps, which it did not used to. Next slide. So the LMI adder incentive, this is a new incentive that just came out for low to moderate income homeowners. It's available to homeowners that are under 80% of the area median income, and it will cover projects up to 60,000 BTU/heating. It is only available for 1 to 4 unit residential homes, and I want to mention that natural gas homes are not eligible to apply for this incentive. Your home has to be heated with something other than natural gas. The adder incentive also only includes heat pumps, so that includes air source heat pumps, ground source heat pumps, and heat pump water heaters. Next slide. So in order to participate in our program, all you need to do is sign up for an assessment for 1 or more of the technologies. And then once that's done, you'll receive a quote from one of our installer partners. That part is completely free. After that, if you decide to move forward with the project, you will then sign a contract and our installer will assist you with choosing incentives and financing that are right for you. Once all that's said and done, installation will start and you'll be well on your way to obtaining energy savings in your home. Next slide. So I'll now pass things over to my colleague, Haley Delisle, who is the campaign director for HeatSmart Southern Tier.
Hi, everyone. Thank you so much for joining us tonight. The next portion of our program is going to be having our installer partners speak for 2 to 3 minutes about their company and what they offer. So we'll start off by having Jess from the Installation Man go.
Hi, everybody. My name is Jess, and I'm with the Installation Man. I'm the project facilitator over there. And as they explained, we deal with the weatherization and energy efficiency side of getting your heat pump. It starts with an energy audit. We come out and we will look at various areas of your house where air leakage and insulation can be a problem. We'll address those areas with you, and if you're happy, if we're happy, the contract is signed, we do the work, and you can proceed with the heat pump. Like I said, we do with energy audits, air sealing, insulation, blower doors for new construction, and, we're just the first step in the project, so.
Okay, great. And we'll have a chance to ask Jess some specific questions during the Q&A. So I'll pass it over to Dave Tierno of AirSource LLC.
I seem to have lost you there, Haley. Can you hear me?
Yep,
Yeah,
I
we
can
can
hear
hear you.
you.
Okay, is the video good or no? Because I'm not getting anything.
Yeah, we can see you.
Oh, okay. There we go. Sorry about the lighting. I'm Dave Tierno. My company is AirSource LLC. I specialize in air source heat pump technology and have for about 10 years now. We specialize in whole house applications. We do partials, but for the most part, I would say 80% of what we do is whole house applications, all different types of distributions. We do work closely with the Installation Man on projects. I can't stress enough how important it is if you have an existing home to really get it evaluated and to minimize the load on the space so that you can save money on your heat pump installation and also on the operational costs. So that's basically what we do is if you're interested, we come out, we set an appointment, we come out, we evaluate the house, we measure the house, all the different variables that contribute to the load, which is obviously the size of the house, the dimensions of the rooms, the windows, the doors, the orientation of the windows, the types of insulation, the thickness of the insulation. All of those things contribute to the load. We calculate the load. We do a design specifically for the house, taking into consideration not just performance, obviously that comes first, but also aesthetic preferences. There's a lot of flexibility with the air source systems. We can do units that go in the ceiling, or a lot of times units that are above the ceiling in an attic and that are ducted to 2 or 3 different rooms. There's certain advantages performance-wise to that. We won't get into that right now, but so we design the system, give you a proposal. If everything's agreeable, then we just go ahead and execute the work. And that's, and then you can just start being comfortable. And the air source systems are just so versatile. You can have, 4 or 5 zones, 6, 8 zones, depending on the house. And you can have each zone be tuned to your preference. 67 in the bedroom, 73 in the living room, all different kinds of delivery methods. So you don't necessarily have to look at a unit on a wall, or, and they're very effective when designed correctly, to temperatures well below 0. So We install in existing homes. We also install in new construction. We do a lot of those types of projects as well. So it really can be applied to pretty much any structure. And residentially, it's a really great solution for a lot of people looking to be more sustainable, to embrace clean heating, and to lower their bills, to be more safe. There's no combustion, and mechanically, it's not, it's not as extensive as some of the other systems. It's a really simplified. The refrigeration technology is very advanced because it has to be able to extract heat when it's 10 below zero outside. Some of the other technologies don't have to be quite that advanced because they're not working with those types of temperatures, but they're also not new. They've been around since Mitsubishi started making these in the mid 70s. So it's a proven technology out of Asia that's just now really getting popular here, and it is growing. Obviously, its capability has improved over the last 5-10 years, and allowed us to do whole houses when we have temperatures at 10, 15 below zero. So we had a customer last year, it was 22 below zero. So anyway, that's pretty much it in a nutshell. We'll talk more in a little bit.
Okay, thanks, Dave. Now I'll pass it over to our ground source heat pump installer, Ryan Dailey. Ryan, are you still with us?
It looks like we may have lost him. In that case, do we want to jump real quick over to our community solar?
Sure.
Just give me 1 sec to get those slides back up. All righty. All right, Adam, how are you?
Great, thanks so much. Before I get started, I just want to just say you guys have been doing a great job. This is our first presentation where the interns have basically done the whole thing, and just want to congratulate you, and also just highlight that for our guests tonight, that we have a program called the Energy Corps. It's an internship that's been running for more than 5 years, and we are well over 100 students through the program. And we're actually going to be publishing a new edition of our Where Are They Now on the website, not too distant future. You can see all the great things these young people go on and do. So community shared solar. Typically solar is either on a property or on a roof, and benefits one customer, either a residential or a commercial or governmental customer. In the case of community shared solar, there are multiple beneficiaries, and it's what's called remote net metered, meaning it's not on anyone's roof. And the way this works, if you could go to the next slide. The way this works is you sign up through our website with our partners, Citizens Energy. And this project is called the Shenango Project. It's on West Shenango Road in the town of Shenango. And all you need to provide for them is one energy bill. And from that, they're able to find how much electricity you use in a typical year. And they will enroll you for that amount of electricity over the year. There are no upfront costs or fees. And the net total result of joining is that you'll receive a 20% savings annually over your supply and distribution charges, which is everything except the flat connection fee. And there's no permanent contracts of any kind. So if you decide you don't want to do it, you can cancel at any time. It does take a little time to get ramped up. Basically, the regulation is that the utilities will only take one list a month from these providers. And so they then have 60 days to take that list and to enroll everybody. So it can take up to 90 days to become enrolled. In this case, you're supporting locally produced renewable electrical energy, and you're also supporting a retired farm family that leased out the property. Next, please. So just a reminder that our next and final webinar for this series is this coming Thursday. And it's going to be 12 to 12:50. It's going to be the first time that we've had a live tour. So Dave Cherno is going to be in the owner's home, and we'll be walking through with his device, showing us the installation, and we'll get to hear from and ask questions of the homeowner. Is Ryan back with us?
We're trying to figure out what happened right now.
All right. Well,
Yeah,
why
I
don't
haven't been
we-
able to get in touch with him. So if you, Adam, would you mind running through his slides or just doing a little overview rather?
Well, I mean, at this point, we should just go to Q&A, and I can try to handle things that he would have. I will attempt to reach him myself, but why don't we open it up now to questions from the audience?
Hi, Adam.
Oh, you're back. Okay.
I don't know. I
great.
got Leah's phone. My computer and phone went bonkers.
So do you want to just take a couple minutes to talk about Dailey Electric, and then we'll go to questions?
Sure. Sorry about that. I thought it was Dave. I thought his heat pump situation was messing with everything in his house, but it apparently was my stuff. Hi, my name's Ryan Dailey.
Oh, that's bad.
I own Dailey Electric and Dailey Geothermal up in Penn Yan. We specialize in small residential geothermal installations. We do plumbing and electric work for mostly residential applications. We install water furnace products. Have installed other stuff, but mainly water furnace is all we install now, mostly AirSource. We get into new construction builds. We do a lot of radiant and specialized air handlers and weird stuff like that with water to water units. But mostly what we do is geothermal. Half our guys, we have 23 guys, and half of them only do geothermal installations. The other guys do plumbing and electric. And that is mainly what our business is. My wife runs the office, and my parents still work the business, and it's pretty small, and that's what we do. So sorry about that. I don't know what happened.
This is life now. We have at the mercy of our wonderful internet system here in the United States. So yeah, why don't we go to questions from folks on the Zoom?
For the question, you want to unmute, or if you want to just put your questions in the chat, we'll kind of go in order of that. So I think I heard someone unmute, so go ahead.
Yeah, so I have a question concerning the insulation that you use or that you recommend or that is required. Can you use wool, not rock wool, real wool, pure wool, animal wool?
Honestly, that's not something I have heard of doing. We do have a number of different kinds of insulation that we use, rock wool being one of them. We use cellulose, we use spray foam, and every now and then we do use Spider Plus, which is an interlocking fiberglass, not like fiberglass bath. So the needs really depend on the home and what areas you want done. Certain areas we recommend different kinds of insulation. So, it would really be a matter of having somebody come out and take a look and talk things over with you. We do have a number of different options that we use and, are more than happy to accommodate try to accommodate the best we can what your needs are.
Thank you.
You're welcome.
I see a message in the chat from RB Ray saying, how much is air source heat pumps more efficient than standard furnaces?
Yeah, I see that. It's a pretty subjective question, but in general, if your furnace is fired with oil or propane, you're gonna cut your bill typically by more than 50%. That's a good kind of rule of thumb that we've seen. If you're a lot of it depends on the existing system, how efficient that is. What kind of duct losses and piping losses you're having. Is it natural gas fired? Because, you know, natural gas is obviously less expensive than propane and oil. But for delivered fuels, the prices fluctuate obviously, but you can pretty much, you know, cut your bill in half or more than half.
All right, I've got a question for Ryan. What is the most efficient type of heating and cooling system?
Forced air, 7 series with an open loop would be the most efficient system you could put in, Scott. Open only simply based on you could get water temperatures pretty high on that open loop. Very rare that it happens. And the 7 series is crazy efficient with everything being variable. Same, or GeoStar Sycamore, same unit. But that right now is definitely hands down the most efficient. With hot water tied to it. Yes, ground source heat pump.
Very nice.
I mean, and don't get me wrong, AirSource is definitely very close. AirSource is right there. There's times when it's the only thing you can do. And there's times Geo, same thing. But a ground source system with a forced air system would just be slightly above AirSource.
All right, thank you. So I've got a question from Vanessa. She says, I'm a new homeowner in upstate New York. I'm trying to figure out how much to switch over from an oil heating system. Almost all of the existing radiators in our home are the old-fashioned cast iron radiators. What would you recommend in terms of moving over to a heat pump system?
Well, let me just answer that real quick here before Ryan opens his mouth. I will tell you, probably Ryan would tell you those old-fashioned cast iron radiators are pretty good for low temperature. If the house is okay.
I will not say that.
No,
No,
I like those
I don't
old
like that
panel
at all.
radiators, and some of those things they work pretty good at lower temperatures, but depending on the house. But I mean, with AirSource, you know, we're in and out of there in a week, and you have heating and cooling, and it's really efficient. I don't, you know, that to me is the solution. If Ryan's not comfortable hooking a Geo to old cast iron radiators, well, I mean, that pretty much is your answer.
Yep.
You know, what Ryan, just for my own education, well, you know what, we won't take up time. I'm curious about that. Maybe I'll check in with you later and get your opinion on that, because
Well, we got a minute, right? Like,
well, low temperature radiant, I mean, like,
yes,
for a modulating condensing boiler, they work great for. So what do you have for water temperature? 120, 130?
Yeah. I mean, so the real problem with that in geothermal is that everybody likes to say we get these 150-degree water temperatures, and it's not there.
Yeah.
So you end up at a 130, and that's just, you know, mid 130s. It's not there. You can come in with an air source system and do it faster and cheaper. We could do the exact same thing with water to water, put air handlers around in certain things. We do it all the time. Cost is definitely more. It's somebody's preference to have Geo over air source when it comes down to that. But hooking up to those old units, like, I'd rather put in radiant through somebody's house, or mix and match a system where we can have different, you know, deliveries of air, instead of hooking back into those. Very rarely do we do that. It's trying to run water to water units at very high temperatures is a very difficult task to make it work all the time.
Good to know.
On that note, I was just about to put in the chat, Vanessa, I would say if you go to our website, which I'll post again at the end, and maybe somebody could send in the chat, and sign up for a home assessment, we can put you in touch with either or both installers, and they can more specifically figure out what would be best for your home. So
that'd be awesome. Thank you so much.
All right, I've got another question from Jules. She says, what's the ballpark cost of a heat pump that will cover 2,000 square feet, including installation? You know, that's a tough one, so I'll turn it over.
If I could, oh, go ahead, Dave.
2,000 square feet. I would say a lot of it depends on how many zones, but typically what's the style of the house? Is there an attic to work with? You know, if it's a 3-bedroom and we can do 3 bedrooms and a bathroom on one zone with a ducted unit, which helps share those small little loads in those smaller rooms. And then, usually, one in the kitchen living room area. Maybe would say maximum 3 zones. You're probably post incentive. Yeah, I would say probably 13, 14, somewhere in there, depending on the types of distribution used. A ceiling cassette over a wall unit adds $1,500 per zone. So there's a lot of variables, and a lot of it depends on the load, obviously. But if the house is reasonable, and we don't, let's be clear, we're not going to put a system in a house that has 2 inches of insulation in the attic. We obviously connect those people with the insulation man to treat that first, and then we can size our system correctly, and keep the project in the nominal range. But I would say 12, 13, 14, somewhere in there is a good number to start with.
Geo would be much more.
Right. That's all the questions I've got in the chat. Does anybody else want to unmute, ask any questions? Hey. Or any questions about how to reach out to us if you do have questions after the fact, or if you want to look more at our website and sign up, that is an option as well.
I have a real quick question. It's
Sure.
Steve. I purchased a hybrid hot water heater in the spring of 2020. And my local utility, electric utility, the co-op, does not have a rebate program or assistance program. Would I be eligible for a rebate program with NYSERDA, or is it too late?
So what utility are you getting your electricity with?
The Delaware County Electric Cooperative?
Yeah, unfortunately, the incentives that we've gone over are all for customers of major utilities. So that's one of the drawbacks. Obviously, as a cooperative member, you're getting really cheap electricity. Oh, you're shaking your head, kind of. It's not that cheap. Yeah,
yes.
You are. Okay. And I honestly have not run those numbers, but you can get a free assessment from one or more of our folks here and find out, if that cheap assessment makes it affordable for you. But unfortunately, that's the way the regulations work at this time.
There is, Adam, I recently did a job here in our municipality, and the customer found some additional rebates that I wasn't aware of through the IEEP, the Independent Energy Efficiency program, I think is what it is, through Syracuse. And she's getting a whole bunch of rebate money that I wasn't even aware was out there. So I'm doing some research on that. But just for people with municipalities, I don't know if the co-ops also participate in that, but that's maybe something to talk to Bennett about.
So I'm going to put somebody on the spot from NYSERDA who's here. Scott, are you familiar with what Dave's referring to?
Yeah, I am, and he got the acronym right. And it's sort of so some of the municipal electric utilities participate in this program, which kind of mimics the one that NYSERDA and the utilities run. So what Adam was saying, everybody, is that the funds that fund our programs, both NYSEG, RG&Es, and NYSERDA's, all come from ratepayer collections on bills from customers that are in their territories. The some municipal electric utilities participate in this independent energy efficiency program, where they collect their own money from their customers and use it to fund projects.
So I would dare say that, Steve, if Delaware Electric participates, there's probably a line on your bill. But Scott, if you could send around information about that, we can put it out on our site and get it around to people. I did neglect to mention that obviously you can take advantage of the federal tax credit for geothermal, provided you have enough tax appetite. That's something where you need to double check with your accountant, tax professional. But that is something that anyone in the United States can use. Doesn't matter whether you're a customer of this or that utility.
Yeah, thanks, Adam. And I'll send you information on independent energy efficiency program. But the best thing to do if you're a municipal electric customer is ask your municipal electric provider.
And if they don't belong, ask them if they could join.
Exactly.
If I'm able to, I'm going to ask another question then.
Please do. Yeah, we've got a lot of silence going on, so nobody should be shy.
Great. Okay, this is maybe challenging, but so I have a wood boiler, and I've that's all I've ever done is burned wood to heat my home. But I'm getting up in age, and I'm getting to the point where I'm getting tired of cutting the I don't know 12, 14 cords of wood for the boiler. Is it realistic? I mean, I'm sorry. I want to head towards electric, because I'm with as Adam mentioned, I'm with a co-op, so I have a very, very affordable hydro power with DCEC. So I realize I would see I would see an increase in my electric bill, but the alternative is when I say I've had enough of cutting wood, I'm either going to go to oil or LP. There's no natural gas here where I live in Delaware County. But again, I'm leaning so much because of my my savings alone on my hybrid hot water heater is like 20% a month. It's literally $20, $30 a month that I've recognized with that application of a condenser. So my question is, sorry to take so long, is that I've got probably upwards to about 500 gallons of water through the loop and the PEX in the house, as well as including about 300 gallons in the boiler itself, which is outside. And I do favor the outside boiler because when I first built my house, my combustion was in the house, and I was always fearful of that. So, if I may just, pick your brains as to, is there any hope for me in the coming years as I grow older that I can convert to an electric heat pump, either Geo or AirSource, that might meet the needs of my home? Thank you.
Yes, absolutely. That's very common. And I would say we do it 6 to 10 times a year, taking people off the same setup you have and tying water to water units into them. Very easy.
To keep my baseboard hot water.
Yep. And then you can put a couple air handlers around and have cooling.
The one thing I didn't mention, and I know there's very little that you could probably add to it, is I live in a log cabin, and it is the ultimate in the lack of insulation.
Mm-hmm.
But it would still be, I could still keep it fairly comfortable, correct?
Yes.
Great. Thank you very much. There's hope for me then. Good.
Yeah, absolutely. No question about it.
Well, I have a question for you. Yeah, Dave, you go ahead, and then I have a follow-up for you guys.
We replace a lot of wood boilers with AirSource, and there's a lot less mechanicals. Obviously, you don't need all the extra pumping. You don't have to worry about, is the baseboard area going to be enough for the house? We can put the BTUs that are needed right in there and the cooling out of the same unit without the extra air handlers. So yeah, either way, AirSource or Geo, both are viable options. Just a lot less mechanicals with the AirSource, but both great options for you. So yeah, we do that. Probably, I would say, yeah, about the same, at least half a dozen a year, where we're replacing wood boilers with great success. So we just did one for a home inspector actually last week. So that was actually a log cabin also out in Milford. So yep, do it all the time. And yes, there's definitely hope for you. So either technology would be great for you.
Thank you.
So I guess my question, and this is maybe to all three of you, is what does get done with log cabins as far as insulation or air sealing? Obviously, you don't have cavities to deal with, right? So I imagine air sealing is one big part of it, but I'm just sort of curious as to what gets done.
Well, I can tell you on the one we just did in Milford, I recommended to the home inspector, who obviously understands the value of air sealing and insulation. He had, well, I gave him a couple options because he has actually a crew of air sealing. He's basically getting rid of his insulation there. They're air sealing with foam guns, the entire flat ceiling, and then they're blowing in, I think, 16 inches of cellulose. And then the vaulted ceiling, he's having Upstate come in and foam that. So, I mean, and he was on the fence about it, but when you really can't overstate the importance of minimizing the load on the house. So, and yes, it's true. The R value of the logs, right? Wood is about R1 per inch. But if you look at how they're put together, there is no cavity. That's kind of an advantage because a cavity with fiberglass, there's air movement through there. You have a solid log wall that's got spines that lock together that have sealer between them. There's not a lot of air that actually moves through there. It's like a concrete wall, similar, right? Not a great R value, but good at stopping air, and a lot of the load is from air infiltration. So it's a trade-off, and I have seen log cabins actually perform quite well as long as the air, the rim, the sill beam is sealed, and the attic is air sealed and insulated properly. So, it's not as bad as I think most people try to make others feel because there's no wall cavity to put an R21 bat in. It's really not the reality of it when you do the load calc.
Jess, do you want to say something about log cabins? I know Insulation Man's been around for a long time. I'm sure you've dealt with them.
We have dealt with them, and it really depends on the house. If they have a basement, a lot of them don't, but some of them may have a basement or a crawl space. We'll look at those areas. If they have an attic, side attics, anything like that, we'll look at those areas. So, it really depends on the house and how it's constructed, and what kind of cavities are going around through it.
Great, thanks. Any other questions? One thing I'll just mention, it has been mentioned, but I want to actually underscore this. With both technologies, you're getting far better and far cheaper air conditioning than you would from a conventional central air or certainly window air conditioning system. And that's something that people don't necessarily always think about, especially at this time of year, but we are having longer and hotter summers. And so though we're still a very much a heating climate, as it's called, we're taking on more cooling climate characteristics as we have more 80 and 90 degree days. I have a geo system in my home, and it's a hydronic system. So I have a couple of air handlers for AC, and they, there's almost no cost to run them. I've got a pump and I've got a couple blowers, that you don't need to have a compressor running for these. So it's a really good deal.
Yeah, humidity control with the AirSource system.
That's true.
Yeah, they can modulate down so low and run so continuously that it's constantly removing moisture from the air. So you have this comfort that you don't get with central air with a big central air unit, 5-ton coming on for 5-10 minutes and then shutting off on a thermostat. So it's a completely different system. Very comfortable, very efficient, and very, very versatile. Can be applied pretty much anywhere. So you can be confident in whatever choice you make. It's all about the contract. It's really all about the contractor, just like anything else. If you're building a house, if you're remodeling, if you're, do your research, get references, just pick the right if the installation is good, Ryan will probably tell you the same thing. I mean, you 90% of the problem, we get called to fix a lot of stuff that's not ours, and 90% of the time, at least, it's a product of a bad installation or a bad design because people don't understand the equipment or they applied incorrectly. I mean, that's just the nature of the beast. So That's really what it comes down to. If the technology is applied correctly and it's installed correctly, you're gonna have a good result.
Yeah, I will. I will say I also suffered from this issue, and one of the reasons why I really, when we were going through the selection process, I was impressed by Dailey, as they were willing to come in and do a little maintenance on my geo system that was installed by somebody who went out of business. And it's, it's not something a lot of operators want to take on, right? Because they didn't do it, and they might be opening up a can of worms. but it's good, and so Dave also does that. I will add something sort of on the policy side that most people aren't aware of, but NYSEG recently set their rates with approval from the Department of Public Service for 3 years. And as part of that rate case, as they're called, they committed to no new gas hookups. And on top of that, New York has a law called the Climate Leadership and Community Protection Act. And what both of these things mean is that there's probably one more generation of fossil fuel HVAC systems that will be viable for homeowners, and then it won't. By the time my 14-year-old is my age, actually much sooner than that, there won't really be much done with fossil fuels as far as space heating and cooling. It'll be pretty limited to applications where we don't have cost-effective solutions. Now, nobody could tell you when this is really going to kick in, and there's a process right now in Albany before the Public Service Commission to plan the drawdown of the natural gas system. It'll take decades, but we want to make sure it happens in such a way that ratepayers don't get stiffed and that low-income folks don't get shut out of the new technologies. All of this is to say that if you can make electrified heating and cooling work for you, you should do it, because it is really, it's not the wave of the future, it's the wave of a now, and you're getting a little bit ahead of the wave, if I may put it that way. It hasn't yet become a mass market phenomenon. It's gonna. And what has me shaking in my shoes is we don't have enough good installers like those on the phone here. We need more, and we need them to either get bigger or clone themselves. So I just thought I'd add that to give you a little context. One more call for questions, or if anyone wants to. Oh, I see that we've got our website up there.
Yeah,
Ellie, did you want to say a few things about it?
Yeah, I just wanted to say, if anybody wants to sign up or get more information, this is our website. If you go to programs and then go ahead and click on HeatSmart, you can scroll down and see sign up for this. And this will go to us, and we will reach out to you, and you can put in additional comments on what you want to know, that kind of thing. So that's that. And then our contact info is here as well. So if anyone has any more questions, we still do have a few minutes, but I'm going to leave this up in case anybody wants to take that down or just make note of that. So
yeah, quick question.
Go ahead.
Okay. I know we're always talking about tightening up the house, cutting down on air infiltration. What would be a minimum blower door air change per hour reading before you think you'd have trouble?
Well, code right now, I think, is 3. So on a new build, and of course we do a lot of new builds that are way lower than that. Houses that are insulated concrete forms or structural insulated panels or spray foam construction. And you just install an ERV. It's not a big deal. You build it tight and ventilate right. That's the saying. So, you'll know if you have problems if your windows start sweating and that type of thing. Probably you don't have too much to worry about in that respect. But if you do get a really tight building and the blower door shows you that it's super tight like that, then you can ventilate it. ASHRAE has a standard 62.2 that governs the design of ventilation systems in buildings, and it's pretty straightforward. We do quite a few of those. Put the system in, deliver the fresh air where you need it to, make sure the system is balanced so you're not in positive or negative pressure in the house, and You know, that's pretty much it. So monitor your RH. But yeah, I mean, that'd be a nice problem to have. I mean, put the fresh air where you want it and in the correct volume for the house.
Okay, I was wondering because when we did have an energy audit, we did have some foam insulation installed. And at the end of the insulation work, they did a second blower door test and it was 0.35 air changes per hour.
At minus 50 pascals, right?
I think
So.
so.
Yeah, that's pretty good. That's tight. See, like log homes, you wouldn't get that. Tell all those people talking about, well, you know, we have no room for insulation. Well, just give them your blower door number. If you have, you know, if you notice if your windows are sweating a lot, I would say, you know, you can go on Amazon, get an RH meter. If you're seeing it drive up in the wintertime, you know, if you're seeing stuff, you know, 60%, 65%, then yeah, you probably want to think about getting some fresh air in there. But that, you know, the house, if you pay attention, the house will tell you. You know, I've got a friend with a SIPS house that has, you know, an HRV system, and he can tell when his system's not working correctly because his windows start, you know, condensating and so on and so forth. So if everything looks good in there, you feel comfortable, you don't see any issues, you're probably okay. But best bet is to at least get an RH indicator and see if in the wintertime, if you're not driving things up, you know, if there's nowhere for the moisture to go, the condensation, you know, depends on your attic. Do you have a vapor barrier up there? I mean, there's all different kinds of variables, but monitor your humidity and if it goes above 60, 65 RH, you definitely want to look at ventilation.
Okay, well, we've never been anywhere near that.
No,
So,
you're fine then.
I'll throw in a little glossary here. Relative humidity is RH and ERV is energy recovery ventilation.
So
one of our jobs is to break down the jargon. So we are actually at time right now. So I think Ellie or Olivia or Haley, do you want to close us out?
I'm happy to. I just want to say thank you so much for everybody who came to this event. It was great. Your questions were incredible. And yeah, if you, we put the links in the chat to our website and to our sign up page. So go ahead and follow those. Reach out to us if you have any more questions. You know, we'd be happy to answer those. So I don't have to say safe driving because we're all at home. So have a great night and look forward to hearing from you soon.
And we will be emailing links to the PowerPoint and the recording to all registrants. So look out for that.
Absolutely. Yeah.
Good night, everyone.
Thanks, everyone.
Take care.
Thanks, everybody.